All right, so today on Breaking Spell, we have a special guest, Dr. Nathan Wolfe, who is a virologist and entrepreneur. Thanks, Nathan, for agreeing to be on our humble little show.
It's a great pleasure. I'm looking forward to it.
Well, I think Douglas, Santosh, and I are delighted at the prospect of being able to spend an hour or so with you talking about a subject matter that you are an expert of, which is viruses and pandemics and how to prevent them. I'll just run through briefly your very impressive bio, which you sent to me. Since 1998, when you received a doctorate in immunology and infectious diseases from Harvard, you've had a stellar career. You were a full professor in epidemiology at UCLA until 2008, after which you founded Metabiota, a data analytics company focused on epidemic risk. And you're currently serving as the chairman of the board. You've been honored with multiple honors, a Fulbright Fellowship, the NIH Director's Pioneer Award, a World Economic Forum Young Global Leader, and National Geographic Emerging Explorer. You've published over 100 scientific publications. Your work has been covered in Nature, Science, the New York Times, The Economist, NPR, The New Yorker, The Wall Street Journal, Wired, and Forbes. In 2011, you wrote The Viral Storm, which, it's about viruses and pandemics and the risk. And I read it when it first came out, and it's a brilliant book. I hope you get back to writing again at some point, because I really enjoyed reading it. And I have to say that it actually, even though I read it 10 years ago, it really prepared me for this pandemic mentally. And allowed me to approach things quite stoically when things started happening. In 2011, you were named one of the 100 most influential people in the world by Time magazine. In 2009, Rolling Stone named you one of the 100 agents of change. And in 2006, Popular Science recognized you as their brilliant 10. But today, you're one of 4 of us. And we're gonna have, hopefully like a fun conversation. So Nathan, just to warm things up, I just wanna ask you, if you can remember, the first time in your life when you felt that things aren't the way they should be.
Well, it's interesting. I would say it probably was, for me, kind of the first recognition of eating animals. So, and I think it's a response that many children have when they, especially in a contemporary world where we're somewhat divorced from farms, we're divorced from production of meat. And so it's perhaps not surprising that it's a surprise what meat is. And I remember thinking, well, that doesn't make much sense, right? I think it was like a lamb chop or something like that. And I was like, well, what is a lamb chop? And I think I just got a blunt answer, which is it's a dead baby sheep. And I was like, that does not sound right. Why does that happen? How can that be the case? And interestingly, I would say that the early issues that occupied me as a child were what would now probably be manifest more as more general environmental issues, but I would say that they were kind of treatment of animals and conservation were 2 of my sort of topics that were most critical for me. And actually that went right through in some ways to when I started my doctoral work, it was actually in primatology. And so it was a little bit of an accident that I ended up studying viruses. I was at Harvard doing work with wild chimpanzee populations with a wonderful professor named Richard Wrangham, who's written some great books. some of which very, very impactful, useful books like The Demonic Male, for example, which questions what of the flaws of contemporary humanity can be attributed to the history of male behavior in primates, right? And it's sort of like if you think about war or murder, and these are by and large male phenomena, right? So they're very interesting human phenomena, but they're also by and large male phenomena. And anyway, so I certainly, another insight that I remember as a child was, I remember, again, like I think all kids do, right? At some point you're like, oh, sorry, we're more closely related to other primates than any of us are related to non-primates. We're more closely related to chimpanzees and gorillas than we are to monkeys. And then actually, I think the realization was really much later, probably not until an undergraduate, where I was like, we're more closely related to chimpanzees and bonobos than either of us are to gorillas. And I found those to be profound insights, and very useful insights in a way that I think is generalizable. I've always joke with my wife, Lauren Gunderson, who's a notable playwright, that that if you want to do good science, all you have to do is look out at the areas in which we believe we're sort of unique or the center of the universe, and call into question precepts that underlie those things. We're at the center of the universe. We are we're sort of created independently of animals, et cetera, et cetera. So many of the major insights into humanity have been about sort of questioning our centrality to the universe or to life or to et cetera, et cetera. And I remember thinking that I actually remember enjoying that insight. It wasn't an uncomfortable insight, and I don't know exactly why that is, but for many people, I think it's an uncomfortable insight. If you look at sort of the history of the response to evolution, and it's somehow very threatening. But for whatever reason, I just found it, I don't know if I found it intuitive, but I found it appealing. And I thought, I just was fascinated with the idea of being able to, when I began my doctoral work, it was really just like, frankly, I wanted to get out and see wild chimpanzees, and I wanted to spend time with them and understand them. That was about it. I was interested at the time at this very interesting behavior that had been talked about, and there was some early evidence of it, which is now sort of this field called self-medicating behavior. And again, similar principle, right? So we assume humans are unique in our use of medications, but of course there's this very rich and diverse set of plant chemicals out there, and it would be ridiculous to assume that they weren't utilized in interesting ways ecologically. And of course that ended up being the case, and there was some interesting work that had gone on in chimpanzees to suggest that they certain plants they seemed to seek out when they were ill, or that they would swallow plants rather than chewing them. And then, it was sort of an obvious question of whether this was self-medicating behavior in chimps. And that was, I think arguably what I was saying would be interesting to do, and sort of to be able to get into a doctoral program. And actually that was what ended up leading me to my own work was, Richard Wrangham, he said to me, retrospectively, he might have been thinking, I don't know if this guy's a primatologist or not, but he said, look, if you're ever going to really get to the core of understanding, what the field needs is not more people to like run around documenting what chimpanzees are eating. We actually need a primatologist to dig into what is the underlying microbiome and virome and epidemiology of chimpanzees, in particular those chimpanzee populations. And and I went through an exercise of thinking of how to document viruses in wild animal populations. And there's been a tremendous amount of work since then, which has really opened that up with great and valuable findings and helped us understand the origins of malaria, the origins of HIV, which are very much ape agents, ape microbes, that without knowing what's going on in wild ape populations, you simply can't understand how these things originate and how they function. But frankly, once I started thinking about viruses and the microbiome, it was just great luck, because studying chimpanzees is one of the most interesting. Spending time with wild apes, the opportunity to do it is something I highly recommend. I just think that and their conservation is something I continue to feel very strongly about. Obviously, it's very complicated because they tend to be in many of the regions of the world that have some of the most challenges with human populations, right? And how we navigate the complexity of prioritizing endangered wild apes, as valuable as they may be relative to, suffering human populations. Again, fascinating topic, and we can happy to dig into it. I guess that's the kind of topic that you all enjoy discussing, but it is a deeply meaningful experience, and you get a much better sense of what it means to be human. What are the things that you assume are unique to humans that aren't? For example, among the things that was so pleasant about working with wild chimpanzees is that often in the afternoon, they will kind of take a rest, do a little siesta. And, the males that, just like human males, can be aggressive, violent, and murderous, are often vulnerable, and there's tickling behavior, and there's all sorts of very intimate play behavior with the adults and the juvenile, very young offspring, and so that's like sort of, again, naively, somehow it's easy to imagine. When I saw it, I remember thinking, well, that was not what I expected. On the flip side, and the other thing is this was a finding of Jane Goodall's many years ago, that chimpanzees hunt, and they hunt pretty successfully, and they hunt collectively, which I witnessed while working with wild chimpanzees, which was deeply fascinating, and is actually quite important for how microbes move through those populations. But one of the things that, again, on the flip side of it, you learn ways in which we assume we're unique and we're not. The flip side was I witnessed a monkey that was hunted and then butchered, and there was no desire to kill the animal before butchering. And it was from a human perspective, a deeply kind of painful thing to watch, because it was just sort of, I'm looking for, probably a liver or something like that. And the notion of any sort of attention to or at least that was the appearance, right? That we pretty much kill animals prior to consuming them. And that was something that, maybe that is more unique. I mean, of course, many predators do, but at least chimpanzees don't seem to have much attention to that. And there was no particular concern for that, which was interesting. Long-winded answer to a short question.
No, that's great. Thank you so much. I mean, that's actually such a coherent thread to your life since childhood, on what has interested and driven you. And it also, it does, like, what I've always been impressed with you personally when we've hung out is how you have always balanced this notion that human beings are not central. We are far from central in this life. And yet you still possess this amazing wonderment at the experience of being human. Like it hasn't affected your delight at the adventure of the human adventure at all. And, I think that's one of the things we try and hold in balance on Breaking Spell here as well. Like, we want to question things like privilege and centrality, without undermining, our own sense of this is great that we're here.
Yes.
So, Yeah,
it would be a shame not to appreciate it, right? This is the you know, I have these interesting conversations. I have 5- and 6-year-old boys, you know, and some of them are very much like having to beat out of them things like I don't know, even COVID related things, right? They at the school, the mortality rates for under 17 are so low. They're below most sources of mortality for children, right? Even in the last year, under 17 mortality has been less than influenza, and much less than, you know, drowning and other sorts of injuries that we don't pay much attention to. And yet at the school, they still say, oh, you wear a mask to protect yourself. No, you're actually doing something more interesting and more important. You're actually wearing a mask to protect others, which is like such a great opportunity to say to kids, like, both to say you don't need to be scared, right? On the flip side, you do need to wear a mask. And that's because we respect other humans, and, you know, that's what we do. The other thing with the kids is science, right? Like science being, oh, scientists know everything. No, in fact, scientists are really only interested in the things that we don't know, right? Like maybe that's a historian, but science would be really boring and nobody would enjoy science if we knew everything, right? And, you know, I think that the other thing I tell them is we are the sort of, we are the universe, right? Because any distinction between us and the universe is just a human construct. So we are a conscious manifestation of the universe. And I would say, like, I guess we don't know the landscape of all of the conscious points of space and time in the universe, but we can guess that among those things on our planet, I mean, other points of awareness on our planet are likely more appealing in one way or another. Like, what does it feel like to be a beehive? Or, you know, would be deeply interesting for us to experience temporarily, but it's pretty good luck to have this capacity to, you know, be on this little kind of watery rock and still conceive of the beginning of the universe. And, you know, and again, we should be humble, of course, right? Like there's so many things that we can't even begin to conceive of, but it's pretty good fortune to be able to have what we do.
So I wanted to open things up a little bit to Douglas or Santosh. You know, I think we have this opportunity to channel some of the concerns about the current situation, the pandemic and vaccinations that we may be in touch with in our different communities here in Singapore. So, you know, Douglas and Santosh, are there any very alive questions you guys have about the current situation?
Well, let me go first with one question I have, Nathan. So, I have a passage from your book. So in your book, you wrote that pandemics, and you wrote this in 2011, you wrote, pandemics will increase in frequency in the coming years as the connections between human populations and the animals in our world continue to grow, whether it's H5N1, a resurgent SARS, retrovirus like HIV, or a completely novel microbe that blindsides us. Microbiome threats will grow in the coming years to plague us, kill us, and threaten humanity in ways that are more severe than volcanoes, hurricanes, and earthquakes. So very prescient statement that you made already 10 years ago. And here we are with COVID. So, you know, my question is twofold, right? So I'm really curious to know what your thoughts are on the current crisis, you know, in terms of the way we are dealing with COVID. And then the second question, which pertains to the statement in your book, which is, it seems to me like one of the solutions, and it's kind of related to your introduction about animals and the centrality of human beings, is that shouldn't the solution be about us distancing ourselves from the animal world instead of trying to get closer? Yeah, because I think like right now there are even some, and I'm just quoting like as an example, like when I watched one recent documentary that had, oh shit, I'm blanking out on his name, the guy who's really famous for being a narrator, David Attenborough. And he did a feature on Singapore actually. And so so in the program, portrays how Singapore is like this very livable city that also coexists with the animal world. But going back to your statement, it seems like we shouldn't be trying to promote that kind of intimacy with the animal world, just for everyone's health and livelihood. Yeah.
Well, first of all, I wish I had been wrong. I mean, let's just say it that way. Or look, and I will say another thing, particularly these catastrophic risks, they're not the same. So what we're experiencing kind of certainly acutely in the part of the world where I live in, I live in San Francisco, with wildfire risk, it is kind of a fundamental and recent change, right? Like it is simply the case that we will experience a greater frequency of wildfires most years probably for the foreseeable future. I don't believe that's what's happening with pandemics. This is a secular trend which has occurred very profoundly over the last 100 years. But I think myself and my colleagues still do think of COVID as being like what we would think of as an insurance industry as being a 50-year event, a 60-year event. So this is a substantive event, and it's not going to be like wildfires in the western part of the United States where suddenly everything changes and we're going to have pandemic upon pandemic. So that is one thing. Having said that, the nature, I often show this image of airline routes, and I think it probably is in my book. Not too long ago, right? Like, I mean, right in 100 years ago, there were effectively none, right? Very few airline connections between populations. And if you go back 50 years ago, it was an order of magnitude less, and now it's just spaghetti, right? The nature of human interconnectivity is such that these viruses, which are constantly pinging us, constantly entering into human populations, have the potential to go global in a way that they never have before. And look, we often forget that even in fairly recent history, HIV now, most people consider AIDS to be sort of more of a chronic disease. They might think of it a little bit more like heart disease or cancer somehow. But certainly as a virologist, I think of it in a way that's very similar to COVID-19, right? This is an animal virus that entered into human populations, then spread globally. And it will be a phenomena that we continue to have. I think that, look, and we should clearly state that COVID-19 is a devastating global event, whether it's for mortality, morbidity, livelihoods. It's one that is not playing out it's playing out in a way that increases secular trends towards inequality. It's playing out in a way that's it's the harm is not evenly distributed within countries and between countries in a way which is deeply inequitable. It hasn't brought out the best in many people. And so having said all that, right, and we could all talk about that for, I don't know, a day or two, but the flip side of it, and this is where I tend to focus, I'm not a response-oriented epidemiologist, and sort of fast forwarded for people watching, which is I did primatology, I became interested in virology, became a virologist, and then have spent most of my career studying pandemics, but not in the way that some epidemiologists do by responding to pandemics to try to control them. That's not my area of expertise. I think about how they originate, and more centrally, how do we set up systems that monitor for them and permit control early on so that we have fewer pandemics, we have more kind of outbreaks and, probably the same number or fewer of outbreaks, but the relative number of if you look at the number of outbreaks that go on to become regional epidemics and pandemics, my objective is, to reduce the outbreaks, but more centrally lately to minimize the number of localized outbreaks that become epidemics within countries and regional epidemics, and ultimately to decrease the number of pandemics, to control these things. And frankly, COVID-19, as devastating as it was, it could have been a tremendous amount worse. And I think people do not realize that. And of course, it's not over, right? And we should, it's worth thinking about that, the not over part. But I still think we don't fully understand why, or I don't follow this literature very closely, and I'm not an immunologist, but as far as I know, I haven't heard anybody compellingly say why, why that earlier thing we discussed, namely the children, seem to be have such relatively low morbidity and mortality rates, right? And if that wasn't the case, with a virus this transmissible, the social disruption and the nature of how it would have manifested itself would have been profoundly different. If we had under 10s have the same mortality rate as over 80s, right? You just think for a moment what that world would look like, right? And that's something that we still don't even understand why that's the case, that it's not like that. Could easily have been, that manifested itself that way, right? We don't have to imagine something totally different. I don't know, I haven't explored this question, so I don't know what SARS death rates were across age groups, for example, which would be probably the closest thing we could ask. But the other thing to say is it's not over, right? That's another footnote, but worthy of a moment, because one way to think of this, if you let me share my screen, I don't know, it's worth looking at an adaptive landscape image. If for those of your viewers who may not be that familiar with them, I'll try to find a good one. Here we go. If I can.
Yeah, I think you should have permission to share your screen. So.
Great. Can you see my screen?
No.
Anyway, the idea of it.
Try again if you want to.
Yeah. Let's see if I can. I don't know how well you can see this image. Is that visible on your screen or too small?
Yep, I can see it. Just like different peaks and valleys.
Yeah, exactly. Peaks and valleys. So if you imagine for the moment that your axes here are, these are genotypes that are modifying over time. And as they kind of move their way up these peaks, they're becoming more, quote, adaptive. In other words, their capability of being transmitted, which is really the main force of selection on viruses, is improving. Okay, but there's an interesting phenomena, which is when you get to this localized optima, any small change in your genotype is not going to permit you to be more adaptive. Okay, so even though this is a virus which is much more transmissible than this one, it's not easy to get from point A to point B. Okay, now, but if you have a lot of viruses that are out in the population, which is the terrible mistake of, right, sadly, many who are not aware assume that there's a static, we're dealing with a static pandemic, which we know clearly now it's not a static pandemic, right? So if you had just a static pandemic and you're like, oh, these are the characteristics, we'll just wait for it to spread to enough individuals and we'll get immunity. Well, but no, it's an evolving agent, so that doesn't really work. And the more individuals that are infected, the higher the probability you'll get a random mutation that permits a virus that's over here that can climb up this hill. And we don't know yet, let's say this is Delta and this is, this is Alpha over here and this is Delta and that's Lambda. And this is, something we haven't encountered yet. So again, my only point there is, these are both footnotes. We don't know how much of the adaptive landscape of those peaks and those genotypic variants and the relative efficacy at transmission have been explored. And the more virus that's out there and the more transmission that occurs, the higher the probability that we will find something which is more transmissible. Now, Delta is pretty transmissible, but has some weird characteristics that happen to be more deadly or kill in a different way, right? So we don't, that's why I make it an important footnote. But with those caveats aside, that it's been, devastating to the planet in a way that is obvious, you don't have to say it, and that we're not done, and there may be variants out there that will evolve that will have drastically different characteristics. I still believe that in the grand scheme, as you look decades out or a century or two out, this does provide an impetus for populations and it provides real-time information for scientists. So the way that I think about controlling pandemics now has evolved very substantially. And obviously, more importantly, the demand that societies will have, that governments will have, that corporations will have to assure safety for their populations will be paramount. And so the amount of investment will be unprecedented because the scope of this disaster is such that it really is not comparable to other disasters that we're familiar with in recent history, other than, perhaps, I guess the world wars. I'm open for discussion on this topic, but since World War II, has there been, HIV is a pretty interesting one. HIV is certainly a worthy, but the economic devastation of COVID is sort of unprecedented. But anyway, let's set that aside, because it's also, is it economic devastation relative to mortality and et cetera, right? There's a lot of ways to debate that issue. The capacity for this event, and this is where most of my thinking goes, I try hard not to think about COVID. And I do think there's also a way in which this is a very privileged thing to say, but like for those of us who are fortunate enough to live in vaccinated communities, if we're not focused on getting unvaccinated vaccinated in our communities, or more importantly, in parts of the world that don't have vaccine, there are other topics for us to move on to. And critical for me is to think about how do we leverage this moment where everybody's paying attention to set up systems and to learn from COVID in such a way that we don't repeat this event again. And I think technologically it's possible. I no longer believe it's going to be costly, and there's going to be compromises associated with setting up the kinds of systems that will eliminate or get us close to eliminating future threats. But I think we have a unique moment, and we'll focus on something else. Let's all remember for a moment 9/11. Like, when was the last time you thought about terrorism? Not very recently, right? But there was, and that will, it's going to take a while before it happens for COVID, but the world will move on from this event, right? And it will start, it'll reach a point, sadly not soon enough, but sooner than we believe, where it'll be like, oh yeah, COVID, oh, epidemics. So now it is sort of this critical moment. The more critical moment where Delta has changed, the Delta variant has changed it, because suddenly, there was a moment where in some populations where vaccination rates are high, people are starting to think forward, and now that's sort of the rug's been pulled out from underneath populations in that respect. But that's where my personal and professional world is focused on. What can we learn from this? How do we leverage the need for these systems, and what can be done? And I think, my own thinking has changed substantially from how it was before the pandemic. I don't believe I've touched on all of your questions, but I've given them a shot there, at least.
Santosh, do you have anything you want to ask at this point?
Yeah, no, I think if there's just one thing, it's why there's been a disproportionate amount of attention to COVID-19 and not enough attention on the epidemiology or the virology of mental health issues, for example, or social justice issues that have been actually festering under the carpet for so long. For me, I'm also interested in looking at the underlying metaphors that we are associating with COVID-19. We are looking at COVID-19 as a war or as a battle. Yeah, whereas like, you know, if and with a war and a battle comes the flip side, which is we become tired and fatigued from this battle as well. And so I'm trying to see if we could reframe the underlying metaphors to something a bit more helpful for human civilization, as COVID-19 being a healthy homeostatic response that Mother Nature is providing to all living and sentient beings on this earth, just to heal itself after years of damage, ecological damage, or just social injustices that we have inflicted upon one another. So one way in which I'm trying to count my blessings is in Singapore, without the presence of COVID-19 last year and the circuit breaker or the lockdown, I wouldn't have appreciated the tremendous amount of value and the important role of our migrant workers in Singapore, who have painstakingly built our country. And you know, the lockdown accentuated the problems faced by our migrant workers, which wouldn't have been possible without COVID-19. Or, for example, the value of our essential workers, or our frontline workers, or our teachers for that matter. So, and also how the digital divide has actually shown how low-income communities are unable to cope with studying from home or working from home. So COVID-19 has exposed so many of these underlying inequalities and fault lines, which has been a tremendous amount of like a source of attention and healing for all of us. And I was thinking, like, you know, why don't we look at it from a homeostatic response that's healthy for all of us? I'm not sure if this is true, but planet Earth or Mother Nature has probably healed a lot more since the lockdowns. There is probably more nature coming back. There's a revival of nature. People are starting to reconnect with their loved ones in a more closer and intimate levels. Yeah, so I'm just trying to see the flip side and the positives of this as well. Yeah.
Fascinating points. And I would say, like, certainly my area of expertise is so specific that I think all of us are equally, you know, and I'll pass it over to, you know, I'll pass it back to all of you to comment on this. I just have a couple of comments. One on sort of looking for upsides and things, one on homeostasis, and one on just an angle on mental health that I think might be worth considering. Somewhat briefly, look, it's adaptive. It's a very interestingly optimistic and I think appealingly optimistic view that you have, right? And I think, of course, it's adaptive and healthy for humans to find positive features in disasters. And it would be wonderful, sort of the more Gaia view, the homeostatic view. And again, I don't profess any expertise in that area, but I am cautious of that view. And I'll give you one example. The example is there's often that's an argument that's sometimes made for vaccination policy, right? So if you look at populations, this was an argument that was made some decades ago in countries like India, where population was really substantial, and there was questions, and some of them were probably rooted in systemic racism or problematic viewpoints, but some of them might not have, which were just like the population is unsustainable, population growth is unsustainable, will not the proliferation of childhood vaccines, sort of, is not childhood disease part of homeostasis controlling population growth? Now and I think it's quite a fortunate finding, it might not have been the finding, was that in fact, when you do vaccinations, mothers and families will control birth numbers better. So you actually see average birth rates go down in vaccinated populations, which is great news on a million different levels. But it also means that nature, the world is handing to families childhood disease, which is influencing birth rates in a way that's smart, right? Like if I'm not going to have X number of kids make it, I need to have more kids to have the number of kids I'm aiming to. And that vaccinations presumably serve to address that. And so, techno-optimism, unity of humanity, not understanding those features, I'll set that aside, not feeling much expertise or unique capacity to comment on them. But I do believe that I'm not a techno-optimist in all particular ways, but I think that in the same way that eliminating smallpox was a really remarkable human achievement of a terrible, terrible scourge that many people assumed the notion of having a vaccine, of successfully getting rid of it, and I think is just a unmitigated positive and a technological humanity positive. And I do have that same view with regards to pandemics, but I'm open on that conversation. Last comment might be just mental health, just probably not worthy of a long conversation, but I do think risk literacy it's not really mental health, it's just my excuse to talk about a topic that I really find. But the other thing is that I think it resonates, Santosh, with your question, which is it's not just a biological phenomena. It's just not just a virological phenomena. Part of the challenge here is risk literacy. I don't know the intricacies of how this is manifesting itself within Singapore, but the world certainly knows how it is manifesting itself within the United States. And it is, I think that I'm very excited by the capacity that I believe we will have in the coming decade to be able to understand viruses in high resolution within populations, all the viruses in a population, right? Not to have this really crappy resolution we have now, which is we have to wait for a pandemic, but to just constantly have always on monitoring systems. And we should talk about that. But I do wonder, no matter how good our systems are, and I do think they'll become really good, some of the biggest impediments will always be human impediments. If we can't compare the relative rates of death, if we can't understand vaccination in the context of a pandemic, if we're not capable of understanding risk literacy, there will be huge social impediments to any systems we develop to try to control these sorts of things. And it's not quite mental health, but look, I completely agree with you, and I don't claim that the current emphasis on this virus is necessarily relevant, necessarily proportional to its relevant impact compared to other systemic issues. One that's always a big issue for me is smoking. Cigarette smoking, it continues to kill something on the order of 6 million people every year, each and every year, dead from smoking. And we're so habituated to this massive source of mortality that, and again, I don't want to get off the topic on smoking, but the media, the human psychology is not literate on risk. And I think it's hugely unfortunate, and not just unfortunate because it's sad that we don't get our world, but it's unfortunate because it has such substantive consequences. So again, I don't want to cut off the conversation about sort of homeostasis and that sort of topic, but that's at least my 2 cents on that subject.
No, I mean, that's great, Nathan. I'm kind of intrigued, because I did want to ask you about like vaccinations, even in Singapore, we have anti-vaxxers. And, it's always a struggle knowing how to respond to them. And I am very empathetic to their position, but I'm also intrigued by this idea of bracketing that and setting that aside and saying, you know what, in 10 years, that is going to be a non-issue. And I want to know more about like what your current state of the art thinking is about how to respond to pandemics.
Look, and I look, part of the challenge though is generals always say, don't fight be careful of fighting the last war, right? So we had the Ebola crisis, and then everybody responded to try to control the future to protect against Ebola events. And we have the same issue with COVID. We don't know what the next events will be like. But I think the opportunity to watch in contemporary, you might hear my 6-year-old in the background. It's about dinner time over here. So it was interesting for me. The people talk about early detection. Certainly early detection is very important. But if you look at what happened in much of the world, United States is a good example, but it's really everywhere. Early detection, whether you knew about the virus a month earlier or a week earlier, would have been important, could have been important. But the most substantive failure was the amount of time that it took to set up diagnostics, which still doesn't occur, right? We still don't actually know the distribution of this virus, right? Our capacity to monitor it and to have dynamic response to it is so limited. That's one thing that I think was a very useful learning experience for me. The other thing is that molecular diagnostics, our ability to diagnose these, has really changed very pivotally over the last decade. And there are new technologies that really permit us for the first time to be able to identify in a pretty simple way all of the viruses within an individual. And I'm happy to talk about that in greater detail. It might be of interest. It's a technology called cell-free nucleic acids. And there's also interesting serological techniques, but where I currently think is that it is a combination of the sort of data analytics and modeling that I've spent much of the last decade thinking about and working on, and molecular diagnostics. And I think it's aimed at smaller population sizes, right? So the way that I think an error that many of us in the community have thought about is, how do we address, to think about pandemics, you kind of have to think globally. But another way to think of it is to imagine populations and try to defend populations. And that's partially been, if you take a look at New Zealand, I mean, I think Singapore to a certain extent, right? For particular populations to be able to manage and protect those within their populations. It's been really, the distribution of success in this has been massive. And so the way I currently think about it is combining molecular diagnostics and modeling in a system which is always on, right? So this cannot be, it's got to be always on, it's got to be following everything. It can't respond to a particular event and then come up with a diagnostic, come up with a testing system, come up with a response system. It has to be some sort of always on system which leverages molecular diagnostics. And I do believe it will be possible to understand all of the viruses in a population pretty much all the time. And that's a bit of a radical thing to say, but I also think it was a really radical thing to say, you know, not very long ago, that you would have in your pocket something that knew exactly where you were and that you could get anywhere you wanted to be, or that there would be satellite images of pretty much every corner of the planet that you wanted to click down on so you could get imagery of. Those were both things that were technological innovations. And I believe the technology either does or will quite soon exist to be able to monitor viruses and to have adaptive response systems. And I think the key will be to, you know, and that's Unsu as a old dear friend and a sparring partner in great conversations over the years. It's a great pleasure to be able to chat with you and be a part of this program. but also Singapore for me is a fascinating place because of for a number of reasons, but it really does for me, and I can get into those reasons, some of which could be misconceptions or my own misunderstandings. I was fortunate to spend some time in Malaysia, so have had an opportunity to spend a little bit of time in Singapore. I lived in Malaysia for a couple years in the 90s. But I really do think is one of these places that may have the potential to set up systems that would permit it to basically know all the viruses all the time and to adaptively respond as threats emerged in different parts of the world to dial up what it needed to do in order to address it. And that ultimately the way the world may ultimately protect itself, certainly that's my current vision and thinking, is that it will be one place at a time. And eventually you'll get to a point where there's enough protection that you start being able to manifest, bigger sort of as I refer to in the book, sort of more of a global immune system, metaphorically. And maybe, Santosh, that's another way to think of it. Maybe it is the same, although, yeah, the metaphor by which we talk about it, it is easy to make it into a war metaphor. And there are some parallels, right? I do think it's a catastrophe on the scale, but this is two interacting living systems like this virus, and it's also a fascinating thing. If we could separate ourselves from the devastation associated with it, it's a deeply fascinating phenomena that we're experiencing. I mean, it's a luxury, and probably inappropriate to think of it in that way, but it's fascinating, so fascinating to see what's going on right now. And it really is one of these situations where that adaptive landscape, what we're experiencing is a virus which is, because of the massive humanity, this massive biofilm that has an unprecedented number and connectivity globally on our planet, it's permitting something which is unprecedented, I believe, in mammalian history, maybe in animal history. I don't know. Certainly the marine systems have different kind of phenomena, but it's a very unique opportunity to witness a mammalian virus be capable in a natural setting of exploring such a wide range of it's only 30,000 base pairs. So it's a teeny tiny informational system. I mean, not as small as you could possibly be. HIV is only about 10 kb, right? So, but it's pretty small, and it's a good question. What percentage of its adaptive landscape has it explored? Sorry, I went off. I don't even remember if I got close to answer. Where were we?
I just wanted you to talk about the state of the art. But hey,
oh yes. So I'm excited. I really do think it's the case that and I think that the amount of investment and need is such that I think there will be countries out there that are going to say, okay, we're willing to set up systems that will really protect our population. And so it does represent an unprecedented opportunity to pull together, and I believe, again, it's going to be diagnostics. Ansu, should I chat a bit about cell-free nucleic acid, or is that a little bit in the weeds?
No, go ahead. We're always trying to challenge ourselves to explain sort of complex ideas in a simple way. So please.
I try to do it for my kids. I do. My poor kids, they're like, Daddy, can we have a story with people in it? Because my wife, I couldn't compete with my wife, who's really one of the more talented storytellers, certainly that I know of. My wife is the most produced playwright in the United States, and is very phenomenal world-class storyteller. And so I don't compete. So my stories are, how did life start on Earth? And what did I do recently? But I do cell-free DNA. I did. So I'll try. I think I can do it. So basically, we all grew up thinking about blood as supplying oxygen to cells, which of course it does. And that's, a main function of blood. And as a consequence of that, blood, by definition, touches all It's a single system and it touches all living cells. We know that because any cell that wasn't touching blood would have oxygen and would die. Okay, so we know that about blood. And what many people don't know about blood is that one of its functions is also related to disposal of cellular material when cells die. And when cells die, bits of their genetic information and all the genetic information that exists in them are eaten up by enzymes, but at every moment you tap blood and you will capture little bits of cellular information from all the cells in the entire body. And that includes from the fetus in a pregnant mother, and it includes, critically, just to get to the end of the story, viruses in every cell. And we've known about this cell-free nucleic acid, right? Because it's not in cells, it's in the blood, it's in the plasma of the blood. But it's been difficult to patch them together. And a very close colleague and friend who I do a lot of work with now, Steve Quake, who could win a Nobel Prize for this, right? Discovered with his lab team ways to put this information together meaningfully into genomes. And you may even be aware of it because it's the reason why amniocentesis is no longer required, because we now have blood tests that permit us to be able to patch together all the little bits of DNA from the fetal cells. And again, cells are constantly dying in all of our tissues. It's just the nature of living organisms. So it's not that there's anything sort of morbid or unfortunate. It's just a natural process of cells constantly dying, lots of them in all of our tissues. And so we now can patch together an entire fetal genome from peripheral blood and not have to do dangerous amniocentesis where you stick a needle, into the womb of a pregnant woman. Similarly, and this was a very important finding with maybe a decade ago, that was again Steve's finding, and I was fortunate to be a part of some of that work, where we basically discovered that you can also find the viruses in cells throughout the body that are dying end up having bits of that genetic information, the RNA or DNA, in the blood, and that you can patch those together. And why and you might also be familiar with, if you've heard of the liquid biopsy, this is also used increasingly for cancer diagnostics, right? And for cancer diagnostics, similarly to the benefit for us in the area of viruses and infectious disease, to really know where cancers exist throughout the body, you would have to do a brain biopsy and a liver biopsy, but now you don't, because cells that have those cancers are dying and they're ending up in plasma, and you can patch together those little bits of genetic information and understand what's going on there. And it's also the case for us, which is one of the challenges that virologists have, if you want to know all of the viruses present in an organism, you basically have to kill the organism historically, because you'd have to do a brain biopsy, cerebrospinal fluid, you would need to do, have gut specimens. And now, and again, this has now been commercialized. There's a company, an American company called Carius, K-A-R-I-U-S, that came out of Steve's lab, that was founded by Steve and a fellow named Mickey Cortez, also a very close colleague that I am fortunate to work with, who commercialized and developed, invented, commercialized, Mickey and Steve and their colleagues invented it, commercialized it through Carius. And now clinical diagnostics, in my opinion, is in the future, clinical diagnostics for infectious diseases will not be 1,000 assays and 1,000 specimen types. It'll be basically a little bit of blood, and you'll know everything operating the entire human system, including the microbiome. And it really is, it's a radical technology and a really pivotal technology. And I mean, again, I don't mean to say that it's sort of one of the, what's happened in modeling has been great. And I've been fortunate to be part of that work. And some of that has really changed dramatically over the last few years, where we could imagine, and I'm not talking about COVID modeling, I'm not talking about agent-based modeling of the basic characteristics of all potential future pandemics, right? So it's kind of fun to visualize. It's the n-dimensional hypercube. I don't know, should we do this again? Do you guys know hypercubes?
I don't actually. Show it to us.
All right, let's do it. There's some great ones. Let's look at like a Hypercube. I'll give us one of these great ones. The like a 10. Let me show it to you. Okay. So this is a representation of an n-dimensional, like a, maybe this is 10 cube, yeah, 10-dimensional hypercube. So the way that you might think about modeling is different parameters. And so in a model, we might start by saying, an infectious disease model, we might start by saying, what location did originate? And that's sort of this first node. And then, right, and we would have to model that for all the potential places where it could start. Then the next node would be, for each of those locations where it could have started, what are the different rates of transmissibility? Might just give you another example, right? And then each of the next parameters have to be modeled out, right? And so this is a way of representing a 10-dimensional space. And computation, and again, I won't go into it in too much more detail than that, but you can sort of imagine, you know, and the models that we now have are, you know, multi-parametric, and computationally, where in the past it would just be impossible to do it, we can start really modeling out, not that these models are perfect, but to model, just like you'd make a model airplane, or, you know, but to model all the future worlds along a certain set of parameters for pandemics. And that really is, again, when I'm thinking of it, I'm not talking about like COVID modeling to try to statistically fit data and predict what's happening in the next week or so, but to say, what are the different worlds that could exist with different possible future pandemics, and to try to come up with systems that can detect and respond to some majority of this kind of n-dimensional space. And that has been a major breakthrough too. And I think it's going to be, you know, where I'm focusing is sort of the Venn diagram between molecular diagnostics, modeling, and population level protection, as opposed to global, trying to boil the ocean and get the planet. And I think it's going to be very exciting. I'm on the road. I'm going to be in, you know, traveling to places in a way that I haven't been doing in a while, and that I frankly had stopped doing in some ways in my own work. Look, and let's just say it this way, I sort of wish that I was able to do something besides pandemics, right? It's very difficult. I am very interested in other things. I really do think that we're missing the boat on things. Smoking is just a plague on humanity, and I think we're getting that wrong. I've spent a lot of time thinking about that topic and working in that area. You know, and I think there are other problems that are related to diet that I've spent a lot of time thinking on. And frankly, I was ready before COVID to move on to a different stage of my career, but you know, I think that's just not possible. And I'm excited by what's going to be able to happen over the next decade. I think it's going to be profound and interesting, and this really might permit us to start doing things on a population level that just have not been done previously, not been possible previously.
So yeah, I just want to let everyone know that we'll run for another like 10 minutes. I mean, Nathan, this has been wonderful. The time has just so like kind of easily kind of passed, and you know, we could do this for another 2 hours. But you know, Douglas, wanted to check in with you. Is there anything you wanted to follow up with, and something that Nathan has said?
Yeah, I guess, well, I have basically a two-part question, so I'll make it quick. So, you know, Nathan, you're talking a lot about how we should move beyond the current pandemic and build systems. And, you know, I think one of the words you use in your book is a control room, right? To monitor future crises or viruses and outbreaks. So I want to go back to something that we were talking about, which was human impediments. So, and I know we don't really want to touch on the idea of the anti-vaxxers, but I think this does pertain to your mission. So one of the arguments, and I'm kind of like personally sharing what I see within my circle, which is the health and fitness industry. One of the arguments from anti-vaxxers is that not so much that they would deny the reality of COVID, but they feel that the focus isn't so much on the virus, but on lifestyle factors. So one argument that comes up from time to time is about, if you look at COVID patients, it's mainly the very unhealthy ones who are dying. So they'll link it to obesity and diabetes, and they'll say, okay, it's more due to lifestyle factors that is resulting in this, huge the death rates, right, due to COVID. And so in a way, well, to me at least, quite cynical kind of way, they kind of reverse the idea of the vaccine mandate and say, well, can you imagine if we had a health mandate and only healthy people are allowed to engage in normal activities, and we, ban the unhealthy folks from, being able to engage in society. So they're doing it in a very crude way, which I don't like. But the idea here is that I want you to be able to address this, because you are a person of authority here, and I feel that the argument kind of misses the mark, right, about them not understanding the nature of viruses, and that it's not principally about just the health style factor. So that's one thing. But basically, the second full question from this is that, hence, one of the ways that they are worried about with the way that we have responded to COVID is that there's this now creation or development of a biomedical surveillance state. And I'm wondering whether, with the work that you're doing right now and you're trying to propose, are we heading towards a model where there's going to be wide-scale surveillance of people? And you mentioned a certain group of people called sentinels in your book, which you will target to see whether they're more at risk of, being infected with a virus. So I'd like you to respond to that.
Sure. Look, one thing I should clarify, when I think about sort of monitoring for viruses and some of the technologies I've referred to, the good news for me is that there's really no need to touch upon human genetics, right? I just need the genetics of the virus, which is fortunate. I believe I'll divide it into two different responses. Frankly, it's above my pay grade to determine to what extent societies should be able to mandate things within their population when it becomes related to population level benefits. I think at the end of the day, it's a complicated issue. You all probably, as better read in the area of philosophy, probably have more interesting to say on the topic. The way I tend to view it, again, just as a practitioner operating within the social framework, is each society has to figure out, each government's going to have to figure out how it's going to function in that domain. I will say my own instinct, and I do think COVID demonstrates this, is, a society which is not capable of enacting vaccination in its populations in a harmful pandemic is, I think that there are many problematic features to that, right? Like, again, imagine that this was, which it could have easily been, it was devastating. And let me state a few things which I think are just fact. Namely, number one, these vaccines are safe and effective. Number two, they help us to manage a virus that otherwise is going to enact huge economic and mortality on our populations. And that most of the reluctance and hesitancy to use them is based on lack of understanding of the relative risks between vaccines and the virus threat that we have. So if this, and I think that those problems could still persist if the virus was an order of magnitude more devastating. And this is a pretty devastating virus. And so I think it's quite concerning that look, and I don't think you have to boil the oceans to, you don't have to necessarily agree to a lot of things that different societies may have different opinions about with regards to what information should be public and private and all those issues. I mean, this is a pretty straightforward health issue that's my read to it, right? This is one that will, and also, look, I'm just going to state it, and I think many people feel the same way. The notion that people would refuse to wear masks is just not only represents a lack of understanding of the risk, but it's also a deeply selfish thing, right? It's just a nonsensical thing. So I don't know, personally, I think that some of these debates about privacy and individual rights and things, you can set them not fully aside. You can't set them fully aside, but if there's any topic in which I think we can agree globally on some of these things, is you have a deadly pandemic spreading through a population. You have a safe and effective vaccine. If people don't use it, like, it's sort of like if people run through red lights constantly, you find a way to make them not run through red lights, because they'll start killing people that obey the law that stops at red lights, right? Like, there are some levels in which we do agree to adopting social mandates that permit us to function as a functional society. And it's hard for me to see the cost to populations of wearing masks. I mean, I don't believe is an issue that you're experiencing in Singapore. But you can't not be, everybody, I assume, like, the absurdity of what's happening in the United States is, anyway, that's just my take. I think that it's not that I'm not interested in issues of individual versus social rights or kind of privacy issues. I find them interesting. And I don't think that there's clear and easy answers to them, frankly. I think they're complicated, evolving issues. But I do think that if there's an area where everybody should be able to mostly agree on, it would seem like this would be one of those, right? Like, even the libertarians, I'm sometimes surprised, right? They're supposed to be protecting kids, and right, there are some levels of protections that even sort of the traditional libertarian mindset would be like, well, children don't have the ability to blah, 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 so we have to protect them. Mentally ill populations. Well, letting this virus run crazy when we know that there are ways to control it, just to me seems frankly unconscionable. And I don't know. Look, I'll pass it back to you all, because maybe I'm missing some of the nuance on this issue, but I think that I'm not sure if I have anything useful to say on the issue of kind of privacy and individual, versus social level responsibilities and those sorts of things. But it just doesn't seem the Venn diagram with that and a deadly pandemic is arguably the one where everybody should be able to agree upon. And when it isn't, I'm just mystified and frankly, I'm baffled.
Yeah, I do have a recommendation for someone for you to look up. Her name is Salome Viljoen, Viljoen, and she's done some interesting philosophical thinking about privacy and data issues. So very roughly, the way she looks at it is our current legal system is very ill-equipped to resolve what you refer to as like population level benefits versus individual costs, because the current legal framework is it's framed in terms of individual rights and how she thinks we should move forward as a society is to have individuals have a say in what our data governance structure should be. So we really need a whole new legal framework. And so, like, let's say for something like your idea, where you want to roll out like this always on, monitoring system for viruses in a population, perhaps a key ingredient as part of that will be like, it would have to be the responsibility of some trust that the people would have some kind of participation in, so that they feel it's in their control, like, and people basically get together and have a conversation. What do we want our society to be, and to have a say in that. And then that's a way of us agreeing, hey, this is a system that will bring a lot of benefits to our population at very little individual cost, and let's do that. So yeah, anyway, that's just.
And again, I do think, just to be crystal clear, I do think that you would lose some, some of the benefits, but you could, the kinds of monitoring systems I envision, at least at a certain level, that would have a tremendous number of benefits, maybe not all the benefits, could be completely delinked with individuals, right? So again, I'm not sure that, right, certainly, let's say it this way, there are some systems that are sadly not as useful as the kinds of systems that I envision, but where you could use sewage basically to get to, right? So I think just as a kind of a thought experiment, I don't think sampling sewage for viral density is going to be controversial to anybody, in the same way that, I mean, it's effectively like sampling air to know air quality. And I think the problem, though, is that won't give us the kinds of, it's useful. And this kind of wastewater monitoring will be something that will be a part of the kinds of the future world that I envision. Sadly, it won't get us all the way, but I do think that you can, between like knowing an individual and their DNA and all, et cetera, and sewage sampling, which is delinked from a population, or air sampling, I think that we can get much closer to this side with the kinds of systems that I envision. And, given the social disruption and cost of these pandemics, I think my sense is that it'll be something that should be able to be created in a way that is pretty universally beneficial. Now, it'll be more beneficial if you can find more information is more beneficial, but finding the point where you get to the point of diminishing returns, my instinct is linking to humans, may not even really be necessary for a lot of what I'm hoping for.
Cool, great. Well, this has been such a informative and thought-provoking discussion. Do you guys have any last sort of comments for Nathan?
Yeah, I can just go very quickly. We do citizen crowdsourcing for citizen sentiments at scale in Singapore. And we've tried to unpack and understand the root causes of vaccine hesitancy in Singapore. And what we realized was the barriers or the reasons for vaccine hesitancy were not informational barriers. The Singapore government has been pushing out a lot of good information to allay fears or allay misinformation. But these barriers were rather emotional and social in nature. So it's, and I think that is where we started to dive deeper into the epidemiology of mistrust. Why was there so much mistrust in just having faith in the government's information? Yeah, and I think that was where the same systems that we've built for modeling, simulating, diagnosing, detecting, and responding to viruses from the biomedical point of view could be applied to having a similar control room for understanding the determinants or the root cause of mistrust between citizens and the government, for example. Yeah. So as I dug deeper into the determinants of mistrust, a word came up in my mind, which was trauma. And now I focus my entire research and study on trauma. It's because maybe there's a collective feel of trauma, and maybe there are some structural determinants of trauma, intergenerational and cultural. If we don't address them, we won't be able to have sufficient political will to have citizens cooperate with the government to do something for the benefit of society. So I think the issues are all very interlinked. Yeah. So we need to not just have one control system or monitoring system for just a virus or viruses. We should have them for trauma, for mental health, for systemic and structural racism in our society, and how those different control rooms link up with one another to give us this broad overview of like, where do we even start when we want to tackle a problem at a local level, which is just viruses, yeah, or an epidemic. Because mental health in Singapore could be actually like more endemic or more long-lasting than COVID-19, for example. And why aren't we giving that much of attention? Why is there not enough political will to build the resources to model, simulate, detect, diagnose, and then treat mental health issues? Yeah. And then now even beyond mental health issues could be trauma, right? So there's systemic, intergenerational, and cultural trauma. So I think all this like systems and problems are interlinked. Yeah. So that's just my take on, yeah, modeling, simulating, detection, diagnosing, and yeah, treatment. Yeah, and how we can apply that to other systems that we have no capabilities or capacities built for.
Good points.
Yeah.
Okay, well, thank you, everyone. Nathan, did you have any last parting words for us here in Singapore?
No, just I'm so grateful for the discussion, and I look forward to doing it face to face at some point soon. Yeah, no, I'm definitely looking forward to that. So yeah, I know you have to Perhaps
go.
in Singapore.
Yes, please do come. We would love to host you and feed you like a king.
Sorry, I wasn't looking for an invitation, but I miss that part of the world. So I do look forward, mostly to hanging out, but I also look forward to seeing that part of the world again as well. So, and to hosting you all, of course.
All right, thanks, Nathan, and good luck with your work and your research.
Thanks again. Great conversation.
Thank you.
Thank you.
Good evening. Bye.